Okay, so what do we do if it's a single-tailed test, like we get to, actually your guys is number 2. Okay, so hopefully you looked at this before you do number 2. I'll try to put a comment in there about that, but when we have a less than or equal to, and you know, it's tough to find less than or equal to sign. You can do it if you come up here, but it's a pain in the butt. So I'm going to express it like this, and if you guys ultimately do that when in the future you're going to have to, okay, this will be fine. Okay, but anyhow, 3 then says a sample of 36 observations, so my n is 36, right, is selected from a normal population. The sample mean is 21, and the population standard deviation is 5. Conduct the following test of hypotheses using the 0.05 significance level, and that is that H sub O, or my null hypothesis, is that mu is less than 20, and H sub 1 is that my mu, less than or equal to, and I got this one written down wrong, okay, less than or equal to 20, right, and then the null has to be the opposite, or that it's greater than 20. Okay, so I'm sorry I had a little error in that one originally, but we got her fixed there. Okay, looks a little bit better. So okay, so it's a single tail, right, because we know that because it has the less than or equal to instead of just the equal to, right? If it's equal to, it's a two-tailed test. Okay, and our significance level is given to us at the 0.05. So now what do we do? You see I kind of have this up here, okay, and what I did was I took 0.5 minus this to get me 0.45, and the reason I did that is we can kind of take a look at this. And actually with this tool, it's we don't need it too much, right? Okay, so oops, let me come down a little bit. Okay, so I'm looking for a z value that's consistent with 45%. Okay, 45.05, 44.95, so it's halfway in between those. So 1.645. Okay, 1.645 if I do a little interpolating, but we can use 1.65, so we can round it up then, right, to 1.65. Again, and we should get used to looking at the chart for that. Okay, and what am I looking for down here? I'm looking for, just in this whole mass of numbers, that 0.4, thank goodness they're in order, but 0.45, and so we know that it's right between there, right, 1.65. Okay, so same, we end up with the same number. Okay, and this is one-tailed, so remember how we did some subtract, or did multiplying by 2 and whatnot. We're not going to have to do that down here, but let's do A. We have to describe what it is. If it's is this a one-tailed or two-tailed test? So it's one-tailed. You guys get credit just for getting that part right. Isn't that amazing? What is the decision rule? So we're going to reject it if it's above the z value. And how do we figure that? Okay, well, our null hypothesis, what we're kind of looking for is that mu is less than or equal to 20. Okay, right? So if mu is greater than 20, which is our null hypothesis, then it can't be this. Okay, and so we're going to reject it if it's above. So I oftentimes, you guys do however it works for you, but I oftentimes say that, you know, for me the decision rule then is to just reject it basically if the null hypothesis is true, or reasonably true. Okay, so reject if we're above the z value greater than. Okay, so then the math is the same as what we've done, and I won't belabor you with that necessarily, but I've got my mean of my x, 21, minus my divided by my standard deviation divided by the square root. So again, I got 5, so 8.833. So I end up just like I did with the other one. Okay, but is that then, okay, is that greater than, reject if it's above the z value? So I'd reject it if it's greater than 1.65. Okay, and I could have put that in here if that makes sense. Reject it if my calculated z value is greater than 1.65. It's not, right? So I fail to reject. Okay, it's almost like accepting the null, but we can't say that. I fail to reject the null. Okay, and then once again it says find a p-value, and since my z is the same as what I had before, your guys' z might be something different, right? But my z is 1.2, you know, I'm going to cruise there. 38.49. Imagine what they did, okay? But it's a one-tailed test, right? And so I'm looking for the chance that it's going to be out in this area, right? So it's just 0.5 minus this, right? 0.5 minus this, okay? And that's pretty simple math. Equal to 0.5 minus my 38.49%, and I end up, so I got 11.5% chance of finding a value that is larger than 20. Okay, I think I got this written wrong because I'm saying this large or larger, but it's greater than, so I think I would say that it's just larger. 11.5% chance of finding a value larger than that.